Hello, welcome to the fourth episode of MLIR code transcription. Today I'm going to transcribe ToyCombine.td, which is in the third chapter of toy language tutorial in the MLIR. Basically, I'm going to type in the TD file and also CPP file here. Pattern matching is done like this. This part is the pattern we are going to match, and then this part is pattern to be replaced. So this pattern is recognized and replaced as this one. So for example, in this case, we have a reshape up and its argument, and also it has one more if one more reshape up comes, then we can eliminate the second reshape up, so that we can replace this pattern into reshape up arg. This is used for optimization and also lowering transformation in MLIR dialect. Okay, let's get started from CPP file. I think starting from the TD file is much better, so I'll remove all of them. Before removing all of them, let's quickly look at the source code. This one's very interesting. We are defining reshape constant as native code call. Looks like this is a C++ code snippet, and you can use a C++ code snippet for the part that we are going to rewrite the matched pattern. So constant, if the constant operation is reshaped, then we can rewrite it to reshape the argument first, and then pass the reshaped constant into constant up. Also, this one is very interesting. This is a conditional replacement, and the condition is here. If we have two reshape, if we reshape after the reshape of a type, if the type is the same, then we don't really need to do the reshape. So just get rid of the reshape, meaning this is a pattern, reshape something, but only if this condition is met. And the condition is if the argument 0's type and argument 1's type is the same, then we just replace with value of the argument. So if reshape x type is equal to x, then don't reshape it, just replace reshape x with x, which is the argument. So we will type in this pattern matching part in TD file.
equals 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 basic pattern match and rewrite equals 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 equals
리쉐이프 리쉐이프 X 이퀄 리쉐이프 X.
Okay, we're done with the first pattern matching. And let's move on to the second pattern matching.
Native code calls may be used for more complex transformations using inline C++ and C++ helper functions.
Okay, we prepared with the small code snippet for reshaping operation. Full shape. So $0.
Reshape op. $res shows how to access the result type of the reshape op.
Yeah, let's move on to the next one.
Equals 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 pattern match and rewrite with constraints. Equals 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 DRR. DRR allows for constraint checking when the transformation is conditional.
On apparent properties.
Reshape x equals x, where input and output shapes are identical.
Okay, we are done. Let's try to compile this code. Mm-hmm. 65. 65. Types are identical. 67. Reshape pattern. Reshape of the pattern. Okay, we are done. So next we will type in ToyCombine.cpp. Let's briefly see what kind of functions we are having here. Frankly, I don't really understand what these are meaning. I think I will get to understand these after transcribing all of them. Okay, so remove all of them and type in again.
Include the patterns defined in the declarative rewrite framework.
Okay, you may wonder what the ToyCombine.inc is. Let's have a quick look at the file. In the build folder, we build the chapter 3. I copied the chapter 3 to TL3, meaning transcription. Not to make the not to change the original file. In this case, we will have generated files in this folder. Tools in the build folder. This is the code we checked out from the original code repository, and we have a build folder which is made by us, and then you can go into tools, MLIR, examples, toy, and originally there were chapter 1 through chapter 7, but I edited these two folders, so we have to go into TR3. Then you can see this one. Here we have a ToyCombine.inc, which is generated from this file, which was the file we were editing right before opening this file. So this file is included in the ToyCombine.cpp. Here, like this. Let's take a quick look at this file. So pattern matching looks like a very great tool for us. Instead of writing all this kind of a boilerplate, we can just write pattern matching directives, and then we can get this code for free. When I first see the pattern matching directives like this, I was wondering what this was meaning, but after generating code, oh, this is making my life so easier. So I really like this one. Okay, let's continue to type in ToyCombine.cpp. Simplify, redundant, transpose.
This is an example of a C++ rewrite pattern for the transpose op. It optimizes the following scenario: transpose, x, x.
Okay, so of course the transpose x could be rewritten using pattern matching directives. Let's try to do it. Simplify redundant transpose. We can use this one, replace with value, and we can just use transpose up arg. So let's try to define it. Simplify. Wow, look at this. Oh, I sometimes really surprised by the Copilot. Copilot already wrote code for me. Wow. I think this is right code. Transpose up arg and transpose up. This one is replaced with the value arg. But we are not using the pattern matching directives. Instead of it, we will write our C++ class by ourselves from scratch, so that we can understand how the pattern matching is helping our lives, making it easier and focus on coding. So OP rewrite the pattern transpose up is the base class.
We register this pattern to match every toy transpose in the IR. The benefit is used by the framework to order the patterns and process them in order of profitability.
Benefit is used by the framework to order the patterns and process them in order of profitability. I want some examples. For example, if you have two patterns that match the same operation, the one with the highest benefit will be applied first.
For example, if we have two patterns that match the same operation, the one with the highest benefit will be applied first. This method attempts to match a pattern and rewrite it. The rewriter, argument, is the orchestrator of the sequence of rewrites. The pattern is expected to interact with it to perform any changes to the IR from here. Look through the input of the current transpose.
Okay, we are getting the operand of the transpose and then checking if the transpose input, and if it is defined by the transpose of another transpose up, then this one is a transpose input up, which is generating the input of the transpose. So, for example, the outer transpose is up and the inner transpose is, so this one becomes the operand of this transpose, and we are getting the defining up of this argument, and then it becomes this one. So this one is here, so meaning transpose x transpose is from the transpose, another transpose. So we can now check if not transpose return failure. Otherwise means we have matched the pattern transpose X. So now this part is going to come. Rewriter, replace up, transpose input up, get operator, transpose input up. Okay, so transpose input up is this one. So we are getting the operand of this transpose, inner transpose. So if we need to implement the pattern matching and replacing for the optimization, we had to write all this code from here to here. If we cannot use the pattern matching directives, then we had to implement all of them. But we have a very powerful weapon. This is a pattern recognition and pattern replacement based on pattern recognition. Next one. So after we create the pattern matching class, we have to register it.
Register our patterns as canonicalization patterns on the transpose op so that they can be picked up by the canonicalization framework. Register our patterns as canonicalization patterns on the reshape op so that they can be picked up by the canonicalization framework.
What does this mean? Oh, I see. Fold constant reshape up to pattern. Here we have created 3 patterns, and after creating these patterns, we have to add it to our framework. So the first one was reshape up to pattern, and the second one is fold constant reshape up to pattern. Third one was redundant reshape up to pattern. Here we will add all of them. These are all related to reshape up, so we're defining in the reshape up. We were overriding the reshape ops get canonicalization patterns. I think I'm done. Let's try to compile this code and if it compiles well. Oh, no. Get operand. Okay, typo. I see. Typo. Get operand. Get operand. And override 49. Const override match and rewrite. Okay, we are done. Now let's take a look at other source codes changing from the chapter 2 to chapter 3 so that we can make some changes to the files. Before doing that, I'll copy my TRT code So this part is for chapter 2. I copied chapter 2 and transcribed the important classes and TD files. Now I copied chapter 3 and transcribed the important files. But one thing missing is the difference between chapter 2 and chapter 3. So I make diff between chapter 2 and chapter 3 and then apply those diffs in TR2 so that I can fully transcribe code changes from chapter 2 to chapter 3. But before doing that, in the TR3 I typed two files. One is ToyCombine.td and also another one is ToyCombine.cpp. So I'll copy these two files into the new folder and then start typing code differences between chapter 2 and chapter 3. Okay, and to see the difference, I created my own repository and checked in all of the chapters from chapter 1 to chapter 7, and they were separated by different commits. So the current head is chapter 3, so we can just get a diff to this one. gdiff. Current head is this one, so I have to provide the commit hash of the chapter 2 so that we can get diff. This is the old one and this is the new one. So in the TL2, let's type the code. This one is CMake list in the src folder. Okay, this file. The new file, ToyCombine.td, was added for the target definition. MLIR table gen is a tool for converting the TD file to files like a ToyCombine.inc. I replaced all of the CH3 into TL2 like this. So instead of CH3, I will use a TL3. Depends. So this one is replaced. Just include is replaced. Right? This one is replaced this one. And TR2 parser pass transform. Okay, we're done with this file. Next one. Only this one? Really? I cannot believe it. I'm gonna run diff once more. Okay, we have more. CMake list. Oh, what's happening? Oh, it's coming one by one. This one is already done, so I will remove it. Remove it. These are all differences I have to apply. ToyC. Let's just start from the simplest one. This one is simply changing the CH2 into CH3, so I don't have to apply these diffs. And this one, ops.td. Just a few lines. Ops.td. OP base was removed. And then pure was added to add up. Pure. It'll be removed if it is not used. The reason. Not used in chapter 2. I don't think it's the right answer. Pure. Another pure was added to mul.
pure tray means it will be removed if it is not used. O. Understand why pure tray was added in CH3 code.
Now I understand why this was added. Enable registering canonicalization patterns with this operation. Reshape up.
Enable registering canonicalization patterns with this operation.
So meaning we have to have a has canonicalizer as one in the def file of the operation to add a pattern matching directives. Has verifier of return up. Necessary. And transpose of is also having pure. Canonicalizer is also set 1. As canonical plus 1.
Enable registering canonicalization patterns with this operation. Indicate that additional verification for this operation is necessary.
I think this is it. Oh, we have one more. It's dialect.cpp. No problem. Let's start from toy.cpp. The top level CPP file. Memory is removed. And after the parser, we have 3 more. Let's just see why these are necessary. I think I have to type all of them because I never typed this in. So instead of making code change, I will skip it but type all of them in another session. But I like this one. Dialect.cpp was transcribed by me, so I can just simply do code fix. Generic callup was added in the dialect.cpp. Add up. After the add up, oh, generic callup. Oh, let me see what happened. Generic callup. We already have it. What happened? Arguments. Oh, I think the callup was moved from between mul up and func up to between add up to func up. Oh, no. It was removed. I was moved after the func up. So I have to move this one. Oh. This one after the func up. I don't know why, but doing the same thing. Okay, we are done. So the final transcription will be transcribing toy.c. But for now, I'll skip it and come back again. Thank you. Thank you for watching. Bye bye.